Who is the greatest experimental physicist of all time? If you ask scientists, many will say Ernest Rutherford. This is the man who split the atom, discovered the atomic nucleus, and laid the foundation for modern nuclear physics. He's often called the father of nuclear physics, and for a very good reason. His story is one of curiosity, genius, and a relentless drive to understand the very fabric of our universe. Born in rural New Zealand in 1871, Rutherford was the fourth of 12 children. His father was a farmer, and his mother a schoolteacher. From a young age, he showed a remarkable aptitude for science and mathematics. A famous story tells of him. Upon learning he had won a scholarship to the University of New Zealand, throwing his spade in the potato patch and exclaiming, "That's the last potato I'll ever dig." It was a turning point that would change the world of science forever. After excelling at university, Rutherford won another prestigious scholarship to study at the Cavendish Laboratory at the University of Cambridge in England. This was the world's leading center for physics research at the time, led by the legendary J. Thomson, the man who discovered the electron. It was like a young aspiring filmmaker getting to work directly with Steven Spielberg. Rutherford was in the right place at the right time. At Cambridge, Rutherford began his groundbreaking work on a newly discovered phenomenon, radioactivity. He studied the mysterious rays emitted by uranium and thorium. He found that these rays weren't just one type of radiation, but two distinct kinds. He named them alpha and beta rays, after the first two letters of the Greek alphabet. Alpha particles, he found, were heavy and positively charged, while beta particles were light and negatively charged. In fact, they were just high-speed electrons. A few years later, a third type of radiation, gamma rays, would be discovered, which were high-energy electromagnetic waves. This initial work was already brilliant, but Rutherford was just getting started. In 1898, he moved to McGill University in Montreal, Canada. It was here that he made one of his most profound discoveries. Working with his colleague, Frederick Soddy, Rutherford realized that radioactivity wasn't just a substance emitting rays. It was the process of atoms of one element spontaneously changing or transmuting into atoms of a completely different element. This was alchemy, but real scientific alchemy. The ancient dream of turning lead into gold was, in principle, possible. They discovered that elements had a half-life, a fixed period over which half the atoms in a sample would decay. This concept was revolutionary and flew in the face of the long-held belief that atoms were permanent and indestructible. For this work on radioactive decay, Rutherford was awarded the Nobel Prize in Chemistry in 1908. He famously joked, "I have dealt with many different transformations with various periods of time, but the quickest that I have met was my own transformation in one moment from a physicist to a chemist." Despite winning the Nobel Prize, Rutherford's greatest discovery was yet to come. In 1907, he returned to England, this time as a professor at the University of Manchester. There, he set up a team to investigate the structure of the atom. At the time, the prevailing model of the atom was J. Thomson's plum pudding model. It suggested that the atom was a sphere of positive charge with negatively charged electrons embedded in it, like plums in a pudding. It was a neat idea, but Rutherford wanted to test it. He designed an experiment that has become one of the most famous in the history of science. It's now known as the Geiger-Marsden experiment, or more famously, the Rutherford gold foil experiment. The setup was simple in concept. He had his assistants, Hans Geiger and Ernest Marsden, fire a beam of alpha particles, which he knew were small and positively charged, at a very, very thin sheet of gold foil. According to the plum pudding model, the positive charge in the atom was spread out, so the alpha particles should pass straight through the foil with only minor deflections. For the most part, that's exactly what happened. Most of the alpha particles went straight through. But then they noticed something incredible, something that simply shouldn't have been possible. A very small number of the alpha particles, about 1 in 8,000, were deflected at large angles. Some even bounced almost straight back towards the source. Rutherford described his astonishment later, saying, "It was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back." This shocking result meant the plum pudding model had to be wrong. There was no way a diffuse sphere of positive charge could repel an alpha particle with that much force. After months of contemplation, Rutherford came up with a new model for the atom. He proposed that all the positive charge and almost all the mass of the atom were concentrated in a tiny, dense core at the center, which he called the nucleus. The much lighter electrons, he suggested, orbited this nucleus like planets orbiting the sun. The reason most alpha particles passed through was because the atom is mostly empty space. The reason a few bounced back was because they had a direct, head-on collision with this incredibly dense and positively charged nucleus. This was the birth of the nuclear model of the atom, the model we still use today. It completely changed our understanding of matter. Suddenly, the solid world around us was revealed to be almost entirely empty space, held together by powerful, invisible forces. But Rutherford's work wasn't finished. During World War I, he worked on submarine detection, but his mind was never far from the atom. In 1917, back in his lab, he performed his final great feat. He continued his experiments of bombarding different elements with alpha particles. When he fired them in nitrogen gas, he noticed something strange. His detectors were picking up particles that looked exactly like the nucleus of a hydrogen atom, a single proton. He realized what was happening. The alpha particle was crashing into the nitrogen nucleus and knocking a proton out of it, transforming the nitrogen atom into an oxygen atom in the process. He had done it. He had artificially induced a nuclear reaction. He had become the world's first successful alchemist, changing one element into another at will. He had, for the first time in history, split the atom. In 1919, Rutherford succeeded his old mentor J. Thomson as the head of the Cavendish Laboratory. He entered his golden age as a leader and mentor, attracting the world's brightest minds to Cambridge. Under his leadership, the lab became the global center for nuclear physics. His students and colleagues, they would go on to make incredible discoveries of their own. Rutherford's influence was immense, not just through his own work, but through the generations of scientists he inspired and guided. Rutherford was a big man with a booming voice and an infectious energy. He was known for being direct and down-to-earth, never losing the practical mindset he developed growing up in New Zealand. He fostered a collaborative and exciting atmosphere in his labs, encouraging his boys, as he called them, to push the boundaries of knowledge. He died in 1937, just 2 years before World War II began. With Rutherford's death, a generation of physics came to an end, but the path he had paved was just starting. His students, Niels Bohr, James Chadwick, and many others, built upon his work and brought in a new era. Without Rutherford, nuclear physics would not have existed. Without him, quantum physics would have taken a different course. And without him, the science of the 20th century, as we know it, would not have developed. He may have passed away before the century's biggest crises, but his impact continues today in every laboratory, every reactor, and in every theory still being written about the atom. That serves as an important reminder. Sometimes the biggest changes in history come from those who simply wanted to understand. Thank you so much for watching. If you enjoyed this journey into the life of a scientific legend, please hit that like button and subscribe for more stories about the people who shaped our world. Let us know in the comments which scientist you'd like to see us cover next. See you in the next video.